Hello everyone, my name is Saul Ojeda. I'm an online tutor at EOP, and in this video I will talk about global water resources and use. This is a video, so at any point feel free to pause it and make sure that you read everything and understand everything before you go up against the AP test. Um, so global water resources and use. So first, let's talk about fresh water and salt water. As we know, they're different. Over 70% of Earth's surface is covered by water. Oceans hold about 97% of all water on Earth. Fresh water is only 3%. So, um, out of the 97% of water on Earth, only 3% is fresh water. Um, and it is mostly found, um, most of it is trapped in glaciers and ice caps. It is also found uh, underwater, underground, groundwater, lakes, soil moisture, atmospheric moisture, rivers, and streams. Unique properties of water. One, water has strong hydrogen bonds which hold the water molecules to each other. Two, the temperature of water changes slowly due to its high specific heat capacity. Three, water has a high boiling point. Four, a lot of energy needed to evaporate water. Water has a very high heat capacity, which allows it to um, absorb a lot of heat without evaporating, which helps our Earth because that way our Earth stays cool enough and it doesn't heat up because the water absorbs most of the heat. Uh, for a lot of energy, again, you really need a lot of energy in order to evaporate water. 5. Water dissolves many compounds. 6. Water filters out harmful UV radiation in aquatic ecosystems. 7. Water adheres to many solid surfaces. 8. Water expands when it freezes. And again, since water expands when it freezes, that's why when the first thing to freeze in a lake is the top of the lake, because it has less density than the liquid in the bottom. Uh, Aquifers. Geologic formation that contains water in quantities sufficient to support a well or spring. Here's a little picture of what a aquifer is. In condition, aquifer, water table, stream, saturated zone, water table, confined aquifer. Ocean circulation. Warm waters near the surface and colder waters at deeper levels move by convection. Changes in ocean temperatures have a direct bearing on ocean currents. Surface ocean currents are driven by wind patterns that result from the flow of high thermal energy sources generated at the tropics, which are higher pressure, to low energy sources in polar areas, lower pressure. Again, everything moves from higher pressure to lower pressure, just like the wind. Um, Deep water, density-driven currents are again, deep water has more density than the water on top. You know, the more dense, the heavier, so you will sink down. So deep water density-driven currents are controlled primarily by differences in temperature and salt content. About 90% the ocean volume circulates due to density differences in temperature and salinities, and about 10% um, is involved in wind-driven surface currents. So again, 90% of the ocean uh, moves due to density differences in temperature and salinities, and only 10% moves due to the wind. Some possible reasons for dramatic increases in ocean temperature include: 1. Significant slowing of the ocean circulation that transports warm water to the North Atlantic. 2. Large, large reductions in the Greenland and West Antarctic ice sheets. 3. Accelerated global warming due to carbon cycle feedbacks in the terrestrial biosphere. 4. Decreases in upwelling. 5. Releases of terrestrial carbon from permafrost regions and methane from hydrates and coastal sediments. Um, Upwelling. It occurs when prevailing winds produced through the Coriolis effect and moving clockwise in the northern hemisphere push warmer, nutrient-poor surface waters away from the coastline. This surface water is then replaced by cooler, nutrient-rich, deeper waters. Deeper waters contain high levels of nitrates and phosphates. When these nutrients are brought to the surface through upwelling, they supply necessary nutrients for phytoplankton, which form the base of the oceanic food chain. Um, Ekman transport spiral. The Ekman transport spiral is a natural process by which wind causes movement of water near the ocean surface. Each layer of water in the ocean drags with it the layer underneath. If such a current transports water away from the coast, it creates an upwelling of deep, nutrient-rich seawater. That's the Ekman transport spiral. Advantages of drip irrigating. Drip irrigating is the most efficient type of irrigation. Why? One, because um, it is increased efficiency. Almost all water reaches crops, no runoff. 2. Less energy is required. Lower water demand results in less pumping costs. 3. Lower demand on aquifers or depleted water resources. 4. Crop yield increases. Fertilizer is accurately applied directly to roots of plants and can be monitored. Reduces salinization and nitrate and phosphate runoff. Tubing systems can be adapted to meet contours of the land and can be changed as needed. Correct amounts of water means plants are neither waterlogged nor water stressed. Now, this is, of course, a procedure in agriculture. And then for domestic use of fresh water, as you can see, flushing the toilet um, use up the most water. Taking a shower, laundering dishes, 20%. Drinking and cooking can also it uses up a fair amount of water, fresh water, and brushing teeth, washing your hands, the things you do on a daily basis, 5%. Surface and groundwater issues. So surface water infiltrates and percolates through the soil into aquifers. Uh, Layers of porous rock, sand, and gravel, where water is trapped above a non-porous layer or bedrock. Recharge zone, surface area in which water infiltrates into the aquifer. If pollution enters an aquifer, the aquifer is no longer a source of safe drinking water. Water table is the region where water saturated soil meets water unsaturated soil. Again, water table, the region where water saturated soil meets water unsaturated soil. Global problems, water shortages. Rate of water consumption is growing twice as fast as the population growth rate. Freshwater shortages are due to reduced rainfall, rivers change course, flooding that contaminates existing supplies, competition for available water, overgrazing and resulting erosion, pollution of existing supplies, competing interests that reduce water conservation programs. Uh, Another problem, rising sea levels, primarily due to thermal expansion of water and melting of ice caps and glaciers. Some other factors like land buildup or erosion of mountains, plate tectonic effects, sedimentation, groundwater and oil extraction, changes in ocean currents and tides, distribution changes in the water cycle. Conservation of fresh water, changes in personal habits, construct dams and reservoirs, desalinate water, drip irrigation, education, encourage the use of recycled products that require less water to produce, engineer systems to collect more runoff, levy taxes or user fees, line irrigation channels and cover canals, meter all water used, plant crops that do not require as much water as xeriscaping, rebates or legislation of low flush toilets, shower restrictors, etc. Reduce government subsidies. Reduce government subsidies. Reprocess recycled water. See clouds. Higher price scale. Use the icebergs. Use more groundwater. That's it, the global water resources and use. If you have any questions, please email us.